All right, here is the worksheet you just sent to me. And it looked like one A and B are good, and C, the one I had a question on, I think here was D. Looks like you're testing it just fine here. I just want to look at this equation real quick. So y equals, I'll show it the way you tested it. So you put in your y value, 3/2 equals, and be 8 minus 2 over 4. I'm just following your work. So that looks good because that's 3 over 2. So that worked, right? We can reduce that fraction right there. So 3 over 2 worked for the first equation. And then for the second equation, we'll put 3/2 over on this side for y, and the math would be 5/4. And we're taking that times 2. That's our x value. And then minus 1. So on this right side, that'd give you 10 over 4 minus 1, which is 10 over 4 minus, and I'd have to have a common denominator. So 4 over 4 is the same thing as a 1. But now the denominators are the same, and that gives me 6 over 4, which is also 3 over 2. So they both do give you 3 over 2. So yeah, it looks like that thing is a solution. All right, so this next one, number 2 here, this is solving systems by graphing. Let's just review here real quick how you graph these things. These are already, or at least this first one is, in that slope-intercept form. So we just graph them. This is always your starting point. That's your y-intercept, and that's where you always start. And so, oh, I got to start there. So I look and I go, it's a 1. So there's my 1 right there. Kind of hard to see which one's your x here. So there's your x. Let's make the x maybe red so it pops a little bit. And make the y red as well. There we go. And so there's my y-intercept right there at 1. And then we just count our slope off. And so it's a rise when y changes by 1, our x changes by 3. That's our change in x. So it's just this ratio that this line represents, or is uh, showing here. So I just started a point on the line, which is that y-intercept that I graphed, and I go up 1 over 3. Boom, there's another point. And I just keep going up 1 over 3. I can put another point. Ooh, I ran out of room right there. I can go up 1, but I can't go over 3. But I can come back down here, and 1/3 is the same as -1 over -3, right? Two negatives make a positive. I'm doing it on my calculator right there. And see, 1/3 is 1/3, and -1 divided by -3 is also, hit my little fraction button there, -1/3, or +1/3 rather. So -1/3, or -1 over -3 is the same thing as 1/3, which means I can also do a delta x, or have my x go, my y rather, go down 1, and my x go down or back 3. I'm just going to go from this point, or any of these points. If I start at this one, I could go down 1, back 3, and I get to this point, down 1, back 3, and there's another point. And when you're solving a system of equations like this, you generally want to put a lot of points because you want that to be relatively accurate. There's my first equation graph. And then this second equation, this thing is in standard form. Okay. So in standard form, which is ax plus by equals c, it's frequently easy to graph it by just saying, hey, I'm going to let x equal 0 and then calculate what y is. So the equation, I plug in a 0 for x and I go, oh, y is 5. So that's a point that's on this line right here. And then make another point. So I'm going to write down 0, 5. And then you'd make another plug in, but this time you plug in a 0 for the y value. And so x turns into 5. The 5, 0 is also on this line. So we just graph those 2 points, and 2 points define the line. So here is 0, 5. I'm starting at the origin, counting up 5, 3, 4, 5. So right there, do that in green, so it's different than the other. And then 5, 0, so that's 5 in the x, but 0 in the y. So I just count over 1, 2, 3, 4, 5 right there. And I draw my line between those two now. I again want to be as accurate as I can. And in this case, I can see this is going 1, 2, 3, 4, 5, down 5, 1, 2, 3, 4, 5, over 5. And so The green line has a slope of down 5, right 5, or -1/1. That simplifies. And that means I can get really accurate with the green one, down 1/1, down 1/1. So all of these points, down 1/1. Oh, that one matched up with the blue line. And see, these points are all solutions to the green equation. The blue is all the solutions to the first equation, and where the two equations share a point, they share their solution. So we just have to read that point right there. Let's see here. It looks like it's over 1, 2, 3, and it's up 2, so they cross each other at 3, 2. And that's the solution to that system. All righty. Now, for number 3, I'm not sure how he wants you to solve this guy. Uh, So maybe you're supposed to test each of these points just like you did in problem number 1 until you find a pair that works. But I took a little inspiration from the previous problem where we graphed it by hand. And I said, hey, I'll just take these two equations. I'm going to throw them into Desmos over here. Inside I threw in the 5x minus 9 and the negative 2x plus 12. And then I just simply have to touch where those two cross and it will tell me exactly the solution. So now I know it's this 3, 6 right here. But then to show it, what you should probably do is just show, hey, does 6 equal 5 times 3 minus 9? And that tells you that 6 equals what? 15 minus 9, which is 6 equals 6. It checks, and then show the check for the second equation. Then you verify that. And then the last one here, uh, Zeke is racing his little brother Nico. They're running a total of 30 yards, so that's their total distance. We better keep that one in mind. Zeke gives Nico a 12-yard head start. Zeke runs, and this is important, this 2 yards every second. That's a rate of change. So Zeke, his slope, that's what rate of change is 2 yards per second. I shouldn't have written it there. It's going to get too crowded. That's Zeke's slope. And Nico only runs 1 yard every 2 seconds. So Nico's slope is only 1 yard per second. No wonder Zeke gave Nico the head start because Zeke is clearly twice as fast. He does 2 yards every second, while Nico only does 1 yard every second. It represents the number of seconds they have been racing. So X is time. All right. And Y represents the distance that is from the start line. All right, fill out the table here for the various distances and Nico are from the start line. So at time 0, Zeke was right at the start line. Nico got the 12-yard head start. Let's see how this works now. At 2 seconds, what happens to Zeke? Well, Zeke is doing 2 yards every second. So in 2 seconds, he covers 4 yards. So he would be at 4 yards away from the starting line. And let's do the same thing to Nico here. Now, Nico started at 12. So in 2 seconds, he's going to cover 2 more yards. So we got to go plus 2. He's now at 14. All righty. Let's do 6 seconds now. In 6 seconds, now we're going to have to do a little addition here for Zeke. So in 6 seconds, he will cover a total of, let's see here. Ooh, we got to make sure we don't want to do 6 seconds. This is a change in X of only 4 seconds. Almost got caught there. So in that interval, that 4-second interval, he can cover 8 more yards, 2 yards for every second, and we're doing 4 seconds. So that's 8 yards more he can cover, but he's at 4 already, so plus 8, he's now at 12 yards total. And finally, we've got Nico. Nico in the next 4 seconds, he's going to add 4 more yards to his. So plus 4 onto him, he'll be now at 18 total yards. Okay, let's take a look at these graphs here, and that will help us. Oh, that's part C, graph it. I'm going to graph it ahead of time here because I think graphing is going to help me with part B. So here's Zeke. I'm going to do Zeke in red. At 0, he's at 0. So this is our time. This is the yards they've covered, or distance. We gotta make sure Y is distance from the start line. Okay. So at 0, he's at 0. At 2 seconds, he's covered 4 yards. Checking my math there. 2 yards a second. 2 seconds gives us 4 yards. And then at 4 seconds later, so now we're at 6 seconds. So way out here, this is where 6 seconds is at. He's going to be at 12. So at 6, he's going to be 10, 11, 10, 11, and 12. So I just got to line that up with my 6 right there. I think that looks wrong though. And the reason it looks wrong is because he's not going to make any curved line here. He should be making a straight line here. So 2, that's 4 seconds. It gives him 8 more yards. That moves him to 12 yards away. So at 2 seconds, he was at 4. And at 6 seconds, going to be at 12. 10, 11, 12. 2, 3. Oh, there's my mistake. Do you see it? So this is not going by ones here, and I counted by ones like it was. My bad. There we go. So at 2 seconds, he's at 4. Well, if they're counting by 2, 4, 6, 8, they're counting by twos here. So he'll be at 2, 4 right at this point. So let's put 2, he'll be at 4. There we go. And then at 6, he'll be at 12, but 12 is right there. So there's what Zeke is doing. But they stopped at, we only know up to 6 seconds. So I'm going to stop my graph right there. And then here's what Nico is doing. We'll do Nico in green here. So Nico at 0 seconds, he was already at 12. So he was right there. In the next 2-second interval, he went up to 14. So he was right there. That's 2 higher. And then he was 18 over here at 6. So let's get our 18, right? It'd line up with him, but it'd be right there. And to get that, I just went up to 20 and dropped it by 2. Remember, it's counting by twos here. So here is his equation. Alrighty, so now they want us to write functions for these things. Based on your calculations, write an equation for Zeke's distance and Nico's distance from the start time as a function of time. So we might do something like distance for Zeke here as a function of time x, unless they've given us other variables and I don't see them anywhere, equals. And so I guess I should do this in red to match the line that I'm trying to write the equation for distance as Zeke goes in terms of x. So here's his equation. And if you look at it, it's got a y-intercept of 0. So if I'm trying to write y equals mx plus b for Zeke, b is just 0. And now I just need to know the slope for this thing. Well, the slope is actually this rate of change. He's covering uh, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. That's the slope of that. That's this rate of change right here. So our slope would be 2, and then we'd have an x there. And so if x is 0, he covers 0. If x is 2, 2 times 2 is 4. We get the y value there. And if x is 6, 2 times 6 is 12. So now we have an equation for Zeke. And let's do the same thing for Nico here. Nico's got a y-intercept of 12. So again, if I'm thinking about y equals mx plus b, let's do them in green to match him. I now know B for Zeke or for Nico is a 12 because that's where he started. Now I just got to figure out his slope. And again, it's taken from this right here. It's 1 yard per second. Now it's a little harder to do it here because these things are incremented by twos. So 1 yard per second is equivalent to 2 yards per 2 seconds. So in that case, it should go up 1, which is a jump of 2 actually, and then over 1, 2 seconds. Up 2 over 2 seconds. And so there's his slope. And so now I've got this equation all figured out. I could write the distance, or Nico here, is equal to his slope is up 1 over 1, so it's 1x plus that y-intercept. Now, both of those, I probably wouldn't have, I'd probably use Zeke of x equals 2x, and I'd probably use Nico of x equals just x plus 12. We don't have to put the 1 in there, but it does emphasize that that's that rate of change, that slope for the problem. Graph both these equations on the grid above. Determine the number of seconds it takes for Zeke to catch up to Nico. How far are they from the finish line at that point? So we're going to continue these lines here, and we're just going to find out where they intersect. Thank goodness I counted my slopes, so I understand them now. So I'm going to do the green one, which goes up to, which is just a step of 1 over 2 seconds. So it's up 2 over 2 essentially. I just keep doing that little pattern here. Even though my up only looks like a 1, remember it's going by 2's. So there's a very, or at least a relatively accurate line of Nico. And now let's do Zeke here. Zeke's going up 2 over 2, up 2 over 2, up 2 over 2, or just up 1 over 1, up 1 over 1. Going by 2 to be a little quicker. Up 2 over 2. You could go up 5 over 5, up 6 over 6, doesn't matter. Up 2 over 2. So there we go. And up 2. And oh, I see a point where they touch each other. And that's a good thing because they're going to cross. And that means the distance they've covered is exactly the same. And it took them, I just looked down here and I go, okay, so this is 10, 11, this is 12 seconds. He caught up with him. I'm going to check my Y here. Find that Y value, just tracing right across the screen. I missed my Y value. So I'm going to erase that. And I'm going to start at my point and work backwards. All right, so start at the point. Now go back over here and line him up. There we go. Now this is 22, and so this is 24 right here. So this ordered pair where they meet each other is 12 seconds, 24 yards. Your seconds, that's your yards. All right, so graph both these equations and determine how many number of seconds. It's going to take 12 seconds. How far are they going to be from the finish line? They will be 24 yards. And that's it. The two lines, y equals, and y equals intersect at that point. What's the y coordinate of their intersection? A piece of cake here. Remember, if they intersect at this point, -2 comma some y value, this -2, when you substitute it in, has to equal the y value. And since we don't know what the y value is, it's just going to tell us what the y value is. So I just grab the y equals 6x plus 15, and I stick the -2 in there. And that'll tell me immediately what y is equal to. Hey, the y must be equal to a 3. So there's no mystery there. I know exactly what the y coordinate is. What's the value of m in this other equation? Well, we have now a really big advantage because I know this ordered pair, this -2, 3, they have to make both equations true. So if I put in the 3 for that y and then -2, not for m, but for that x, that's the xy pair that makes it true. The only thing I won't know is the m in there. And that m I can solve for. So here I'm going to set it up. My y is -3. I don't know what m is still, but I know if I take it times -2 and subtract a 4, so that's what the equation says, the left side has to equal the right side. I'm going to clean this guy up just a little bit. -2 times m is this. And now I'm just solving this guy for m. Add 4, add 4, add 4. 1 equals -2m. It looks like this has a slope of 1 over -2. But we usually write it with the negative on top. They're both equal to -1/2. So what's the value of m? Gotta be -1/2. All right, that is it. Hope that clears that all